Hi everyone. From today, I'm going to start a new coding series, and in this coding series, I will focus on Client 75 lead code question. So I will try to cover all the Client 75 lead code question, and our sole motto will be not to just solve the coding question, the 75 coding question that is given here, but try to grasp all the concept that is possible using all this given problem statement. So we'll pick up the problem and try to cover as much topics as possible, and we'll try to understand the logic behind that and how we can solve such kind of similar problem in the real interview. So let's start with the first problem, two sum. Okay, so here let's read the problem statement. So we have been given an integer nums and an integer target. So we need to return the indices of the two numbers such that they add up to target. You may assume that each input would have actually one solution, and you may not use the same element twice. And you can return the answer in any order. So it's not always guaranteed like you can return 0 1, you could return 1 0 also. Okay, so let's try to understand this problem using any of the input. So I will going to choose the first input to understand the problem better. Okay, so I've just taken the input, and let's try to see. So we have been given this input nums array. Okay, so the elements are 2, 7, 2, 7, 11, and 15, and the target is 9. Okay, so this array could be of any nature. It is not guaranteed in the problem statement, like it will be sorted in nature. So it could be sorted or unsorted. So make sure to check all these things. Otherwise, if we assume like the array will always be sorted, then there could be a test case where the array is not sorted and our algorithm will start failing. Okay, so this array could be sorted or unsorted. So let's try to come up with some approach to solve this problem. So one brute force approach could be to solve this problem is to run two for loop. And while running the for loop, we'll just check the sum of the elements that we are currently processing. If the sum is equals to the target, then we are good. We can return the indices. Okay. So for this one, the time and space complexity, let's try to calculate. The time complexity would be n square since we are going to run two for loop. And space complexity would be order of n since we are not going to use any extra space to solve this problem. So can we do better? So, yeah, let's try to think some another approach that is more efficient with respect to the brute force approach. So the second approach using which we can solve this problem is sorting technique. So not only sorting, sorting with two pointer technique. Two pointer technique. So in this one, like what we can do, first we need to sort the array. Okay, so the first step would be to sort the array. So when we sort the array, we could have like 2, 7, 11, and 15, and after that we can go ahead and choose two pointer technique. So after sorting the array, we could have 2, 7, 11, and 15. Now we have to perform the two pointer technique. So in two pointer technique, we take two pointer and we can initialize the first pointer at 0th index and second pointer at last index. So let's represent your first pointer with L and second pointer with R. So in two pointer technique, like we have this sorted array, we have two pointer pointing to the first and last. Now we just need to find the pair sum. Okay, so let's try to calculate the sum of the current element that is at index L and R. So the sum would be 2 plus 15, that is 17. And if you see, like this sum is greater than the target for which we are looking for. So definitely, like we need to reduce this, or we need to choose the pair whose sum is lesser than the current one. So for that one, what we can do, so as we go, since the array is sorted, as we start going from right to left, then we will see the array nouns value would be smaller than the previous one. So that's why here we can reduce our r value by 1. Okay, now r will start pointing here. Now again we'll perform the same thing. 2 plus 11, we'll check its summation whether it is greater than or equals to or lesser than. So here it is again greater than. Then what we will do, we'll proceed ahead in the leftward direction. Again r will start pointing here. Again we'll perform the same thing. 2 plus 7, that is 9, that is equals to the target. So I'm just going to return the corresponding index. That is r is pointing at index 0 and r is pointing at index 1. Perfect. So up to here I don't think that we are having any issue. Hope it is visible to everyone. Okay, so let's calculate the time and space complexity of this approach. So for this one here in this algorithm, we are doing two things. First is the sorting one. So we are performing the sort operation. The time complexity for the sort operation, let's say like I am choosing the merge sort or quick sort, then the time complexity would be n log n. And after that we just have two pointer and we are just iterating the entire array. So in worst case, like we need to iterate the entire array, the time complexity will be order of n. So the total time complexity or overall time complexity for this approach would be order of n log n. What about space complexity? Are we using any extra space here in our approach? So no. So we are just using few variables. So the space complexity would be order of 1. Because the space that we are using, it's not a function of the input array. So it would be order of 1. So can we optimize the time complexity further? Let's see. Can we do it better? So yeah, we can do it using. So let's try to optimize the time complexity further. So the third approach could be hashing technique. So these are the standard techniques, both the technique that we have discussed, two pointer technique, sorting with two pointer technique and hashing technique. These are the standard techniques that you can apply to solve any other similar questions. So I could provide the reference for some similar question, but yeah, let's first stick to the concepts. So in hashing technique, what we can do and how can we utilize the hashing technique to solve our current problem. So here we have something like some array, 1, 3, 2, and 5, or let's say like 6. And let's say like our target is 5. Okay, so we have to achieve this target. So we know like x plus y equals to the target. So at any point of time, if I am processing any element, then I will start looking for the corresponding element. How can we find the value of the corresponding element? So let's say the corresponding element I am representing using y, then it would be equals to the target minus x. So at any point of time, if I am processing any array, I will just start looking for the another element. If it is present in the array, then we are good. Otherwise, we can go ahead and start processing for the remaining element. Let's try to write on your approach or our approach using this input. So here we have this. Let's say like I started from here and I am going to use a hash set so that we can perform the quick lookup, because we have to perform the quick lookup here, that is target minus x. So if you use the hash set, then the time complexity or amortized time complexity for the get operation or contains operation or quick lookup operation would be order of 1. Okay, so in our hash set currently it is empty. So I started processing this element. I will check the corresponding part. So 5 minus 1 is 4. I will check whether 4 exists in this hash set or not. So definitely it is not existing. So I will start going and processing ahead. I will just insert the current element that I have just processed. For 3 also I will start looking for the corresponding element. 5 minus 3 equals to 2. Whether 2 is present in this hash set or not. So definitely 2 is not present. So I will go ahead and start processing for the other element. Since I am done with the processing of this 3, I will just insert it here. Now for this 2, I will start checking for the corresponding element. So 5 minus 2 is 3 and 3 exists here. So we find the pair, and the pair are 2 and 3, whose sum is equals to 5. Now, if we use the hash rate here, then you can see one challenge we could face here, because in our ultimate question, we have to return the indexes. And in hash rate, we are just putting the element. We are not considering about the indexes. So instead of using the hash rate, the better data structure would be a hash map. Hashmap also provides order of one time complexity for doing the lookup using get method. So we could use hashmap. The approach would be same. So instead of just storing the element, I will store the corresponding index also. For example, here I could store. Let me write it here. So instead of just storing one here, I will store both one and its corresponding index. For three also, I will store the corresponding index. And as soon as like we started processing for these two, we will check here. Like we know the current index I, we will check here. Like yeah, this is existing. So I will just return the indexes, and the indexes would be for these two index currently I am processing is 2, and for 3 here I will fetch the index that is 1, so I will return 2 and 1. Because while returning the order, we don't have to follow any particular order. We can return the answer in any way. So if you want to return 2 1, it's good. If you also want to return 1 2, it's also good. So let's try to calculate the time and space complexity for this hashing technique. So here if you see, we are just doing a linear iteration of the given array, and in between, while processing the element, we are doing a quick lookup. We already discussed the time complexity for a quick lookup in hashmap is also order of 1. So the overall time complexity of this approach would be order of n, and the space complexity would be order of n. Because in worst case scenario, we need to insert all the element into the hash map. I hope you understand all the three approaches that we have just discussed. So let's do a quick revision for all the approaches that we have discussed. So we started with the brute force approach, and we understand its time and space complexity. So the earlier time complexity was n square. Then we came up with a sorting based approach from brute force approach. We see its time and space complexity. We see like it's optimal little bit with respect to the brute force approach. We have reduced the time complexity from n square to n log n, and the space complexity remains same for both the brute force approach and the two pointer technique. Now we came up with an optimal approach with respect to the time complexity. We use the hashing technique, and in hashing technique, we see the time complexity is order of n and space complexity is order of n. So here, if we compare with the sorting technique or the brute force technique, then definitely with respect to the space complexity, we are taking here much space. But with respect to the time complexity, hashing technique is the optimal one. So depending upon the configuration where we need to run this code, we could choose either the sorting technique or the hashing technique. So let's say like I have a use cases where we are building or writing this logic or this piece of code that we need to run on a small device, let's say like on your watch. Then in watch, definitely like we have very limited space. Then in such cases, like we can avoid, like even if it is taking few millisecond more millisecond to process with respect to the most optimal approach, then it's good, we can do that. But let's say like we are writing this piece of code for any general application, then definitely like we can say like we can assume like this space is not a constraint for us, and we could prefer hashing technique because the time complexity here is more optimal. But yeah, depending upon the configuration where we need to run this actual piece of code, or depending upon the constraint on which we have to apply this technique or this, we could choose either the hashing technique or the two pointer based technique. Okay. So yeah, that's all. Let's do a quick coding for these problems and try to submit the code. So I will just go ahead and code for the optimal solution. Okay, so in optimal solution, where like we discussed, we should have a map. In map, we would store the element and its corresponding index also. We know the nature of this map. It would be of integer and integer. We need to return a pair. Let's say like we have this array and its size would be 2 because we know like we have exactly one solution for this problem. While returning the result, you can take a call and in any order you can return it. So it's not a constraint because we have seen here in the problem statement, you can return the answer in any order. Okay, if it is existing in the hash map, then it's okay. Like we find our answer and at that place itself, like we can return. Don't need to do the further processing. Otherwise, we'll just insert in our map corresponding element and its index. Even if we have duplicate element, then we don't need to worry about that one. Definitely the indexes, like we can return any pair. So it's not a constraint for us because let's say like I have a duplicate element 2 which is at index 3 also, then definitely like for this 2 I'm going to update the its index using the current logic. But as per the problem statement, like we have exactly one solution and yeah, then there are high chances like they will not contain the duplicate element. And even if they contain the duplicate element, we know like there is only one solution, so we are sure like our solution or our approach would work. So let's try to validate for some of the other test cases to ensure the correctness of our approach. Just by seeing or running your code on a single test case doesn't ensure the correctness of your approach. So let's validate it on some another test cases. So yeah, for all the test cases I see like it is working, then I think we are good to do the submit. Okay, so here if you see like we are facing some exception. So it's related to unable to create thread. So it's possibly not related to our code, but due to the system constraint that this lead code is currently having, they are facing some out of memory error. So these are the kind of error that definitely can't be handled through the code. So let's try to perform the submit again. So here you can see like this is accepted now. So yeah, that's all I have from mind for today's session.